Okay, here we go. Here's a video about how to use GeoGebra on the goodness of fit. Particular one where the expected values are by proportions. I wanted to use this real data. So I wanted to show you this real data I found back in 2014. In 2014, a man named by Michael Brown was shot and killed by police officers. A man, well, actually, he was an 18-year-old young man that was shot, an African American young man that was shot by police in Ferguson in 2014. And here I have data from 2013. From Michael Brown's death. Michael Brown's death was kind of what set off essentially in a media frenzy of watching and telling the public essentially about deaths and police brutality of our African American population in America. And so that death basically sparked Black Lives Matters movement. Don't quote me on that, but that's when essentially it started around that same time with Michael Brown's and quite a few others that had happened around the same time. And then from there, the issues continued throughout the years, and now here we are in the summer of 2020 with George Floyd's passing, and we're still in this situation, though hopefully something will come out of this. We'll see. Um, so so here's the thing, right? So there's basically two opposing sides to this argument. What's going on? African Americans and many other people who believe it as well and believe about the systemic racism embedded within the police department are on board with defunding the police. Defunding the police can mean many things. But anyways, I don't want to get into that argument. What I want to do is I want to prove systemic racism was within Ferguson before Michael Brown was shot and killed by police officers there, essentially proving what the African American population of Ferguson was saying all along and why they were so frustrated with this police department. Things have changed now. They're doing much better than even we are here in Sacramento. Of course, that's not saying much from Sacramento. Stephon Clark. All right, so I want to prove the systemic racism. So what I have over here, so this was the original data. I just wanted to show it to you. I have moved essentially the stops, the number of stops of essentially in that year of white people versus black people, Hispanics, and so forth and so on. So I moved that data over into a column data, as you can see. So these are our observed values from 2013. And so if the police department was essentially saying there's no systemic racism in there, then what we would expect to get out if there was no systemic racism involved, and I've already just calculated this, right? We would expect a proportional number to the population of people in Ferguson. So, right, so if we look down here at this data, right, the local population percentage, why am I not just highlighting this local population percentage, but this row here gives us our local population. Ferguson is very African American, has lots of African American people comparatively to whites or Hispanics or Asians or American Indians, right, or Native Americans as we say. So, all right, so here we go. So here's the number of stops, the total number of stops. This is our total, right, of our number of our observed values. And to find these expected values, all we do is take this total and multiply by the percentage of the ethnicity group in Ferguson. So, right, I would take 5,384 and multiply by 33.56%, right? So we have to kind of convert that to a decimal and so forth and so on. And so I already done this and taken this away from you to be able to talk about this a little bit quicker here, right? Because I really just want to show the benefits of GeoGebra and how we can do GeoGebra. So these are what we would expect out if there was no systemic racism within the community, right? We can see already there is a big difference in what we expect for the number of people stopped. right, in Ferguson for our white people and our black people, and essentially showing already within the data that, right, we should have seen 1,800 white people being, right, pulled over and stopped, right, as opposed to 686, which has actually happened, or vice versa. If there was no systemic racism, then we wouldn't see 4,632 African Americans being pulled over that year. We would see more like 3,400, right? African Americans being that, right? So a much larger number actually happened for African Americans, a much smaller number actually happened for whites, as many people have been saying throughout the years, right? So this is the systemic racism that we can essentially see right with these numbers, but hey, we're in a stats class. Let's actually prove it with a hypothesis test. So I want to do a hypothesis test. Whoops, that's not what I wanted. Delete. Sorry. Delete row. Oh goodness. Who cares? So I want to do a hypothesis test. So first thing we need to do for a hypothesis test is we need to come up with a alternative and null hypothesis. So null hypothesis. And we also need an alternative hypothesis. Right? So we need these two things first. So a null hypothesis here, right? The null hypothesis is we're assuming, right, that what we expect is true. So what did we expect? We expected that there was no systemic racism, right? So, and I know again, right, I'm trying to prove, right, that there is systemic racism, and don't worry, we will, right? But the alternative hypothesis, right, is that systemic racism is apparent in Ferguson. So but let's write it in the words that we use for our class, right? So so the null hypothesis for a goodness of fit is that the number of stops in Ferguson in 2013 is what we expected. Whereas the alternative hypothesis would be the number of stops in Ferguson is what we expected is not what we expected, right? So does not fit the data. So maybe I should say that is what we expected and fits the data for null hypothesis. So our alternative hypothesis is that the number of stops in Ferguson does not fit the data. Control C. So I'm going to just copy and paste this. The number of stops in Ferguson in 2013 is not what we expected, would be the big difference. And I'm going to use caps here. It is not what we expected and does not fit the data. Why do I have fits here? Okay. And does not fit the data. Okay. So with that in mind, let's go through this this hypothesis test. So that is the first step. So step one. So, and I should be writing that down too. Step one. Step one is so step one is write the null and alternative hypotheses, right? So step two is what? So let me write that out too. Write the null. So step one is write the null and alternative hypotheses. Step two is find the p-value So step 2 is find the p-value. Step 3, just to kind of get them all down here, step 3 is decision time. And step 4, we are going to write the conclusion. So these are all our things that we do. I'm really just going to find the p-value here, and then we're going to make our quick statements, because I really want to make this short and about using GeoGebra. But I'm going to do this in my regular lecture video to make sure that we understand what's going on here with this stuff. So, so let me just kind of make these headers. All right, and let's say, so step 2, find the p-value. So first we find the test statistic, first we find the p-value and the test statistics. So let's go to GeoGebra. So let's go to GeoGebra and pull up GeoGebra, and then we'll find out what we have here. So leaving that open, let me go to GeoGebra. GeoGebra says, and we need to start the calculator. No, okay, so we're going to go to GeoGebra. So how I got here was essentially I went to, let me go back to GeoGebra, and I went to GeoGebra Classic, and then I clicked on probability. From there, we got statistics, right? And so we've been doing this for a little bit, coming into the statistics place. So that shouldn't be hard. If I pull this down, if we look right at the bottom, there is a goodness of fit test. This chi-squared test is what we'll use in the next unit. So, but right now we're using a goodness of fit test. So if I look at this, I then get essentially a table out that we can put values in, right? And I need to label how many rows I have. So 1, 2, 3, 4, 5, 6. I got 6 rows, so I'm going to put 6 rows here. We got our observed amounts. We can even label them, right? We can even label them if we want to. White. Let's go ahead and do this. I'm just interested to see why not black. We don't have to do this, but this would be interesting to be able to show people what's going on with this. And I will actually share this little thing, a little image of this also on our solutions. So American Indian should be Native American. Should I just rewrite it? No, I won't do that. But so let me type it all in. So it's going to take a second. Let me pause the video. I'm going to type it all in. You can do this at home too, and then we'll talk about the results. Okay, now that I've entered the data here, I'm looking at this, and right, GeoGebra gives us some nice little totals down here, and I'm not really sure why this total is not adding up to that total. They should, though I haven't used GeoGebra on this before, this problem, but I have done this problem before. And they kind of should add up, so I'm thinking the percentages are a little off that are given to me in my data. But that's okay. Let's just work with it. It's relatively close enough that we can work with this. All right. So and it is our real data that we want to work with that the police officers have put out there for the community. So let's use it and try and prove the systemic racism involved. So we did this. We already did this. So what we actually found was that the p-value is equal to 0, which is the p down here, and the chi-squared, the test statistic, is this huge chi-squared test statistic. We've been looking at this stuff quite a bit now. We understand p-values, right? This is a very low p-value, so low that GeoGebra cannot even calculate it for us. That's how small this thing is, so we call it 0. Right? But the probability, remember the p-value is the probability of something happening, right, given that we expect the data to fit our expected values. What is the probability of getting the observed counts when the expected count should be this is 0. So is what that's saying. So that tells us that there is a huge difference between our observed counts and our expected counts probability-wise. It tells us that the chance that this occurred by chance alone, the probability that this occurred by chance alone, this set of data, given that this is what we expected, is 0. AKA, something is happening within the Ferguson Police Department to cause this big of a difference. And that is systemic racism, right? This is systemic racism. This is the definition of what systemic racism is that people are not being treated the same because of their color of their skin and other things as well, as we know, right? These are, so this is just the tip of the iceberg. All right, so I just want to show that and put that out there for y'all, right? The main thing is we're using GeoGebra to be able to do this, right? And find the p-value really easily and find the chi-squared test statistic really easily. All right, hope you enjoyed this video. Here we go.